Hi Girls in STEM team, our names are Stepan and Karthik, and we present to you LabPocket. LabPocket is a 2D and 3D interactive platform where students can explore science, math, art, geography, and music through hands-on virtual experiments with real-world objects. Now the problem here is that most STEM tools hand a student a static diagram or a video, and neither one lets a student reach in and build something of their own. LabPocket solves that by giving a student 7 full interactive subjects built entirely on real physical models instead of scripted animations, so they get to express themselves in a field and actually understand why something happens. Let us show you how it works. Here I'm clicking into chemistry, and this generates a full 3D playground. On the right side is the import panel, where users are able to import real chemistry equipments like beakers, tubes, and burners directly onto the playground. And once something is imported, they can click and drag it anywhere they want. If a user clicks on an object, a small blurb pops up describing what it is, and they can click Learn More for a more in-depth explanation of objects and reactions. Over on the left side is the tutorial panel, and I'm opening one called Classic Fizz right now, rated difficulty 1 out of 8, so I follow the steps. Import a beaker, import a tube of vinegar, import a tube of baking soda solution, click the vinegar to select it, and click the beaker to pour it in. Then click the baking soda and click the beaker again to pour it in and watch it fizz. Every subject carries 20 of these tutorials, so there are 140 total, each rated for difficulty, and users always have a harder one waiting once they finish this one. Moving on to physics, it looks similar to chemistry, but I'm importing different materials, like a battery, a switch, and a light bulb. Looking over to the left, this tutorial wants us to light a bulb, so I wire the battery to the light bulb and watch it light up. And adding a switch into that same circuit means opening it kills the circuit, and closing it turns the bulb back on. Beyond circuits, users are able to launch projectiles, swing a pendulum, and explore optics with prisms and lenses. Moving on to biology, I'm importing organelles, dissection tools, and genetic models instead. This tutorial wants me to compare a plant cell and an animal cell, so I pull both onto the playground and look at what's different between them. From here, users are able to walk through the stages of mitosis or fill in a full Punnett square to predict a genetic cross. Moving on to geography, users are able to take a look at the tools geographers actually use, like a satellite globe and real landforms, before moving into the natural disasters. I bring some human buildings onto the playground and start testing them. So here I'm setting off a hurricane and hits the buildings with wind and rising water, then I trigger an earthquake right next to it and a wildfire after that, watching how each one of the 52 disasters affects the same buildings differently. Moving on to music, I start on the piano, playing across the keys. Then I pick up the guitar and pluck through the strings, and finish on the drum kit, hitting every drum with each instrument carrying its own personalized sound. Switching to math, I'm able to type in a few different functions and compare their graphs side by side. Then click along the curves to drop points and see exactly where they land. Moving to art, it opens as its own full-screen drawing studio, and here I'm able to draw a smiley face, switching between tools as I go, since each one of the 76 tools has its own feel. We are Stepan and Karthik, and this has been LabPocket. If you would like to be creative, you're free to visit the demo link and try LabPocket for yourselves. Thank you to the organizers for setting up this awesome hackathon, and thank you for watching.